It's it's recording. Uh, okay, so where was I? Okay, specifically, he'll talk about um, the fight for Navigator's planned pipeline currently before the Illinois Commerce Commission. There's also a battle to stop planned ADM Wolf pipeline. Meanwhile, in Springfield, we're helping to promote a bill to fill the legal vacuum in Illinois on laws related to the capture, transport, and sequestration of CO2. So Rick, who is a trained climate reality leader and Sierra Club activist, was born and raised in the UK. He came to the US to get an MBA at Stanford and has lived in Lincoln Park since 1976, where he and his wife raised two daughters. His home is often on the Chicago solar tour, and Rick gets his power from rooftop solar supplemented by community solar. And his job was at Accenture as an IT consultant until he retired as a partner in 2000. So why don't we welcome Rick to the meeting tonight, and let's get started.
Great. Thank you so much, Tom. Really appreciate it. And it's great to be back with Climate Reality. I did my training in San Francisco in 2013, I think, with Al Gore for a few days there, and it was great. And I did a whole series of lectures after that, and then I got dragged into other things, and I haven't done any recently, but I certainly enjoyed working with Climate Reality, and I have a lot of respect for the work that you guys are doing, and particularly the weekly list of things we can do to sign petitions and so on. That's great. Anyhow, how many of you, just a show of hands, have heard much about carbon dioxide pipelines before? 1, 2, 3, 4. Okay, some of you have. Okay. The rest of you, if you haven't, don't feel bad about that. This is something that's come really out of the blue in the last year and a half or so. I never heard about any consequence before. All of a sudden, we heard that Summit Pipelines was working in Iowa, and shortly after that, we heard that Navigator Pipelines was coming to Illinois. And I was at that stage doing another ICC battle with the Dakota Access Pipeline, but it had come to a sort of a hiatus, and we're still on that one. But these pipelines came up, and my little not-for-profit soil decided it was a good thing to try and get involved in that. And so we've been working on it for now a year and a half or so, and it's going to be quite a battle. The reason that we hadn't heard much about CO2 pipelines in the past is that there were, first of all, very few of them, about 5,000 kilometers in this country and very few anywhere else. And they're almost exclusively in rural areas in Texas. When they mean rural there, I mean there's nobody there. So they go through basically open land, some are on the surface, and they almost always go from a natural occurring source of CO2, like a dome in a volcanic dome, where they can suck it out when they feel like it, and where it wouldn't normally get in the atmosphere at all. And they transport it down a straight pipeline to an oil well, where they pump it down the oil well for the purpose of freeing up more oil. And it's called enhanced oil recovery. And so it's a very simple operation, a small pipeline going for a short distance. And most of the time, they have no problem with it. We'll talk about some of the problems later on. What we're talking about here is a whole different breed of cat pipeline. We're talking about pipelines that are 1,300 miles, 2,000 miles long. They're all starting off from man-made sources of carbon dioxide. Primarily at the present moment, they're talking about ethanol refineries, where they go through a brewing process, basically like fermenting the beer, that naturally throws off carbon dioxide. The reason that they like those ones is that the carbon dioxide comes off almost completely pure, just slightly wet. You dry it, you can pump it up to a high pressure, pass it down pipelines, and transfer it to other locations relatively easily without a lot of energy being used. And then you can sink it in the ground. And 2 of the 3 major pipelines that are underway at the moment are coming to Illinois, because Illinois just happens to have a very favorable geology. 7,000 feet down underground in Illinois, there is a sandstone layer with a lot of saline salt water, very, very salty water, that you can pump the CO2 down into. This is the theory, and it will stay there forever. That's the theory. And the reason it's supposed to stay there is because there's a 500-foot thick layer of shale called the Eau Claire sandstone right above this layer of the saline. And in theory, that's going to keep it all down there. That's the theory. So a lot of more pipelines will be coming towards Illinois over the next many years if we aren't fortunate enough to stop them. Let's go on to some slides now. I'll just show you my slides and we can go from there. I'm showing that screen, that one. Okay, can you see a slide now?
Yes, we can.
Can? Okay.
Perfect.
Pipelines, all pipelines are dangerous to some extent, but CO2 pipelines are considerably more dangerous than any other pipelines there are. And we'll get into why that is. The sequestration process, oops, come on, move. Next slide. What's that? Well, for some reason I'm stuck on one slide. I don't know why. Don't bear with me for a moment to try and find out what's going on. Should be able to see that now with a bit of luck. I think what's happening is I've got the Zoom instructions over the
battery 40% connected.
Oh,
We can't see it now.
I know it's I don't understand why.
We'll do this for 45 minutes.
Bear with me for a moment. Let's see if we can get this going again. I'm going to stop screen sharing and start again.
Ah,
Okay, here we go. Let's try this way. Okay, that's better. Okay, there are three phases.
Yeah.
Can you see it? No? No? Okay, try again. Share screen. How about that?
yeah.
Good, okay.
Perfect.
So sorry, little technical problems here. Anyhow, the three phases. First of all, the carbon dioxide has to be captured. In the ethanol case, it's a piece of cake. You know, say it comes off almost all pure, and you can dry it fairly easily, and it's ready to be pumped around. There are other situations that we're planning on doing sequestration in Illinois, such as the huge Prairie State Energy Complex down near St. Louis, which is the dirtiest or the biggest single source of CO2 in Illinois, and the 7th largest in the country. Produces about 12 million tons of CO2 a year, which is an awful lot. And it's all going right up into the atmosphere right now, along with a lot of other pollutants. So nitrogen oxides, sulfur oxide, particulates, and of course, being a coal-fired power station, it also creates tons and tons of coal ash. So it's a very dirty process, and it's made more so because the oil down there is all, the coal is sort of lignite, so it's very particularly dirty. And they plan to capture it there because there's a thing in the recently passed Climate and Equity Jobs Act that says they either capture 50% of their CO2 or they get shut down. And so they're desperately trying to find that. But for a coal-fired power plant, it's a very difficult process in capture. It can take about a third of the total output of the power station just to do the capturing work, so the parasitic load. And when they capture the CO2, they don't capture the extra particulates. So if they had to turn the power station up 30% to produce the power, or put even another power station alongside it, as they sometimes do, they don't capture the CO2 from the other power station, or they don't capture the particulates. It makes the pollution even worse. And so there are significant problems with other sources of CO2. So capture is not always easy. In fact, it's very difficult. Transportation is a relatively straightforward process. You build a pipeline, you put a few pumping stations along the way to keep the pressure up, and you move it from point to point. Now, the difference between a CO2 pipeline and a regular oil or gas pipeline is pressure. In order to make the CO2, which is normally a gas, into a liquid for pumping efficiently, you have to pressurize it to a minimum of 1,072 pounds per square inch, and you're more likely to keep it around about 2,200 pounds per square inch, which is like 3 times the pressure you use for oil or gas. So you have to build the pipelines a lot thicker. The welds have to be made a lot more carefully, and it's just a more difficult process to build the pipeline than normal. If you've got your pipeline there, then the destination is either for storage, where you take it out of the atmosphere and, as I suggested, pump it underground and leave it there permanently, or for what I mentioned before, enhanced oil recovery, where you take it to an oil well, pump it down the oil well, and hope most of it stays down there, even though there's probably lots of other wells in the area where it could leak from. And then it dissolves the extra oil that's left in the oil well. Then you pump that all out, and you separate out the CO2 that comes out with the oil and pump that back down the hole again, and so on. Not a very, it's a completely, with enhanced oil recovery, a completely carbon positive process. You get all the energy required to capture the CO2 and to move it around. And then when you pump the oil out, you burn the oil, and that produces a whole lot more CO2 than you save in the ground. So not a good thing to do. But one of the most common form of using CO2 at the moment is enhanced oil recovery. A tiny amount of it goes to things like carbonation for soft drinks and beer and things like that, but that's a minute amount compared to the other ones. So first process then is to capture it. In the case of things like Prairie State, you use chemical processes and lots of water to capture the CO2 out of the smokestack, and you use a nasty chemical called amines, and that gets gradually used up and turned into a carcinogenic product which you have to bury in a landfill. That isn't the case for CO2 pipelines. There, it's just a matter of drying it and pumping it. Then you remove it, and then you pump it in the ground. So that's the 3 parts of the cycle. Okay, now let's see. We got to move ahead. I've never had this problem before.
You hit page down, does it work?
Page down is not up. Well, it did work that time. Okay, so these are the maps of the 2 CO2 pipelines coming into Illinois that we know about for sure. The first one is called Navigator, and you can see it collects CO2 from ethanol refineries throughout the Midwest. It's going as far afield as Nebraska, South Dakota, Minnesota, a whole lot of places in Iowa, and then it comes down and picks up from one small location in Illinois, in Galva, and it pumps the CO2, it hopes, into one of 2 places. The first one will be in Christian County, which is somewhat to the west of Springfield, and the other one is a little further than that, called Montgomery County. They're actually doing test drills in the Montgomery County one, which is the southern one here. They'll be drilling, they're going to be 24 hours a day. It's absolutely deafening. They've got 20-foot high sound barriers around the drilling process. They're using so much water that the water pressure in the locality is so low people can't get any water out of their taps. And the ones that can still get water, it comes out brown because the amount of water they're taking is stirring up sediment that's in the pipeline. So a very dirty process. The other pipeline is the Wolf ADM pipeline. ADM is one of the biggest corn processors in the country, makes lots of agricultural products. They happen to have a location down in Decatur, a very large ethanol refinery, and makes many other products from corn down there, like corn syrup and so on. So they already have been using a demonstration project in Decatur to capture CO2 from their ethanol process. It's the only actual running CO2 capture process in the country, other than for oil from the volcanoes and the like. It's doing 500,000 tons a year of sequestration. But the plant, as we'll see later on, produces about 8.5 million tons of CO2 because it happens to have a coal-fired power station there. So these are the two pipelines that we're fighting at the present moment. Okay, page down and hope. No, no. I do not understand what's going on. We'll keep trying. Oh, there we go. It went forward. Okay, the pipeline companies will tell you CO2, that's the same stuff you put fizz in soda. It's what's in your fire extinguisher. Well, it's chemically, that's correct. It is the same product. But when it's put into a pipeline at 2,000 pounds per square inch, 2,400 pounds per square inch, and liquefied, it is not the same thing at all. It's a very, very dangerous product. And we'll get into that in a second, if I can get this thing going. What we have next is a demonstration of what happens when things go wrong. This is a test explosion of a very small pipeline. It's only an 8 inches in diameter pipeline. The total amount of CO2 in the system is about 153 cubic meters. It's about 1/48 the size of a pipeline I'll tell you about a little later on. So very, very small. So this is just an idea of what goes on.
This video shows a rupture of a buried, dense phase carbon dioxide pipeline. The experiment was conducted in a safe environment. The DNVGL Spadeadam Testing and Research Centre to assess the consequences of such ruptures in terms of mass outflow, rate of formation, and dense gas dispersion. The viewer should note that the extent of the visible plume does not necessarily represent the extent of the dense gas hazard.
As I say, it was a small explosion, and you can see that the CO2, well, you can see that the plume, I should say, spreads out along the ground. That's because the gas is heavier than air, and so the air floats above the plume. The other thing is that the plume is extremely cold. The reason being that when you take this liquid CO2 and you remove the pressure, it has no choice but to turn into gas. And when it turns into gas, it has to take latent heat of vaporization out of the surrounding atmosphere and the surrounding pipes and so on. And therefore the pressure, the temperature of those pipes goes down, and temperature in the air goes down. What you saw in that white cloud is primarily condensing moisture in the air, just turning into dry ice because of the temperature. And that plume therefore spreads out along the ground, and it goes downhill when it has a choice. And if you happen to be in the basement of a house, let's say, and this gas pours into you, you will be dead in a very short period of time, 10 minutes in many cases, if the density is enough, if enough points per parts per million, can kill you in a minute or two, but most likely it's going to certainly make you unconscious. And we'll tell you about how that happened in another instance. So you see, therefore, the normal, it's a gas, it's compressed into a liquid in the pipeline. It's a solvent. It's a wonderful solvent when it's a liquid. In fact, any of you who had a glass of decaf coffee today, the caffeine was probably taken out of your coffee by dissolving it in liquid CO2, the wonderful solvent. But it also tends to dissolve hydrocarbons, and it also dissolves the seals in normal valves and so on. So it's not easy to deal with. The gas in the pipeline is quite sensitive to things like hydrogen sulfide and sulfur dioxide in the pipeline, and it can change the way it behaves when it's in the pipeline and how it explodes. When it does explode, you can see in that example, it turns into an extremely cold gas, and the dry ice part of it's minus 109 degrees Fahrenheit. So it's not good to be around it when it blows up. And the other thing you saw in that example was that the explosion started off relatively slowly. It was exploded by exploding a little dynamite charge above the pipeline to create a hole. As time went on, that hole got a lot larger, because the cold makes the pipeline extremely brittle, and therefore you get what they call running ductile fractures, where the pipe unzips just like a zip fastener on it. And instead of being a small leak, you have very, very quickly an extremely large leak. The pipeline empties out. How far it empties out depends upon how far apart the valves are. The valves may be set to close automatically on a pressure leak. Not necessarily. Some of them have to be closed by instructions from a remote control center. But the standard distance for pipeline valves is 20 miles rather. So if you've got 20 miles of pipe coming out of a hole like this, you've got hundreds of thousands of gallons of CO2 coming out, and it just spreads around. Pipeline zips, the leak get big very quickly and with very little warning. So you can't go around and detect a leak and say, okay, I've got time to fix that one, like you can do it from an oil pipeline or a natural gas pipeline. Large volume, it can travel a long way, over 1.5 miles, as we'll see. As I said, there were very few of these pipelines around, but there was one bad example of an explosion in one of these pipelines in a slightly populated area. It happened in 2020 in Sartatia, a small village, about 50 people living there, but nothing more than that. And the people lived 1.5 miles away from the pipeline. In fact, they had no idea that the pipeline was there. When the thing erupted because of a lot of rain that caused a landslip and caused the pipe to break apart, they were completely unaware that there was a pipeline close to them. Not only were the residents unaware, but all the first responders in the area were unaware of it too. And when it first erupted, they had no idea what it was. They thought it was a chlorine leak from their water treatment plant or something like that. And it was 7 o'clock at night and so on, so people weren't at least in bed. And they could hear the noise of this leak. It was a very, very loud rupture. But they started feeling faint. Some of them fainted. Some of them had seizures. Some of them jumped in their cars and tried to drive away, and their cars stalled because they need CO2 to run. The emergency people came in on 4x4s, and their vehicles started stalling as well. Fortunately, they had some oxygen tanks with them, so they could get the 50 people out, and they actually took 200 people who were in the vicinity but further away. They were evacuated. The 50 people were taken to hospital, and the hospitals had no idea what to do with CO2 poisoning. They didn't know what it was when they arrived. And they sent people home sometimes, and they had to go to a different hospital the next day. Some of them, even though it's 2 years ago, are still suffering from the after effects of this CO2. Here's a picture taken many hours after the erosion. There's a small, you can't really see it, the pipe coming out of the ground just about there. This is the 40-foot wide, deep chasm that the pipeline blew up, exploded this 40-foot crater. It traveled 1.5 miles, not in a straight line. It went around a hill and came back on the other side of the hill and so on. And it caused a lot of illness to a lot of people there. Okay. Now, there are, as I said, relatively few of these pipelines in the country. Most of them go from these little blue dots, which are the naturally occurring sources of CO2. There are also the yellow squares you can see in there. Those are things like fertilizer plants, where it's also fairly easy to get it. They're all short. They don't go very far. They go point to point from wherever the CO2 is available to these circles, which are where there are oil wells. They can pump them down. So they're short. They're usually small diameter. They go point to point, so they're easy to manage. It's not a problem maintaining the pressure there. Because if the pressure goes down low enough and this stuff starts turning into gas, you need a different kind of pump to move it around than you have when it's liquid. So it's very difficult to manage. So this is just the extent of CO2 pipelines in the country. The pipeline that blew up was this Denbury Green pipeline here that's in Mississippi. Okay, now that's just the big tip of the iceberg. There is an incredible amount of focus and attention on CO2 pipelines and sequestration at the moment, largely because the oil and gas industry says, as long as we can take our natural gas-fired power station to the CO2. Question? Okay, I thought I had someone say them. Capture the CO2 and put it underground. We can keep on using natural gas. Same thing with coal. If I can capture the CO2, even though I'm going to create a whole bunch more other pollutants, I can at least say I'm not contributing to global warming, and I can keep on using coal. So I can keep on using the CO2 to do enhanced oil recovery, so I get my oil back cheaply. In order to do this, Princeton University did a plan that showed they would need 60,000 miles of CO2 pipelines in order to, or 70,000 miles, it says here, in order to capture all the CO2 and in any case, move it down to the Gulf where it can be used for enhanced oil recovery. So these few thousand miles that we're looking at right now is potentially just the tip of the iceberg. And the reason it's happening is because in the Infrastructure Act and the Inflation Reduction Act, the value that the government will pay you to sequester oil was increased from $30 a ton to $85 a ton. And if you do it for enhanced oil recovery, you only get $60 a ton, but then you get paid $40 a ton by the oil company. So you come out ahead there. So there's this great rush to sign up sources of CO2 that are easy to handle. And that's almost entirely these ethanol plants in the Midwest. So we're the focus, the tip of the spear on this lot, where companies are going around signing up these ethanol plants, agreeing to take their CO2 for a certain amount of money, say $50 a ton or $20 a ton, and then the ethanol refinery keeps the balance. So this could be an enormous problem, and a lot of these things will go to Illinois because we have the right kind of geology. Okay, so why are we concerned about this? Well, public safety is nowhere near ready for something like this. A lot of these rural counties where the pipelines are going to go have volunteer fire departments. There's nobody there most of the time until the fire comes, and then they all rush to the fire station. It can take hours in some cases, 15 minutes, 20 minutes to get anywhere. You could be dead by that time. And they don't have the kind of equipment you need, like an electric fire engine or electric ambulances that would let you get into these areas and save people. So there are lots of problems there. They are planning on using, the pipeline companies are planning on getting the right to take your land by eminent domain, which means that whether you like it or not, they're going to come in and force you to give them an easement to put this pipeline through your farmland or in the vicinity of your houses and so on. We're fighting that one in the Illinois Commerce Commission. From a farmer's point of view, this is a terrible thing to have happen. When they dig these pipelines, they do dig trenches like you can see here, but this is not a trench in a high quality farmland area. It doesn't appear that they separated out the good topsoil, which we have in Illinois, from the lower clay soil, which you don't want to, not really very, very fertile. So they're supposed to separate out the kinds of soil, put one on one side of the pipeline, one on the other side, and put them back in the reverse order. It doesn't happen that way. The guys who build these pipelines are not farmers. They just shovel it back in the fastest way they possibly can, usually. And so you get mixed and low quality soil at the top. When you bring these big machines in, you don't see any of the big machines here, but there are much heavier machines that can pick up these long lengths of pipe and lower them into a trench. Those machines compact the ground so it will not let water go through. And so you get drainage problems to compaction. A lot of the farms in Illinois have what they call pattern tiling, which is a set of tiles 40 feet apart, 40 yards apart, I think it is, that are perforated, that take the water away so that even if you had a very heavy rainstorm, it won't flood your plants and kill them. These pattern tiles cost $1,000 an acre to put in, and they're very, very delicate, and they have to have a certain fall going down inches per 100 yards of fall, just so the water flows out, and they're laid out in a very careful pattern in order to capture the water. When these pipelines come through, they'll interrupt these, they'll just dig these pattern tiles up and throw them away, and they say they'll come in and repair them. But once they've been disrupted, it's really, really hard to put them back again. So you'll have wet spots occurring, and the pipelines in some cases will back up with water, low spots and so on. So that's a serious problem. They say they will pay you 100% of the crop loss in the first year, 80% in the second year, 30% in the third year, and so on. But we've seen situations, particularly in Dakota Access Pipeline, where 8 years after the pipeline was installed, they still haven't got their crop yield back anywhere close to being the maximum, and the pipeline stopped paying them a long time before that. The other thing is, if you put one of these things through your land, you probably won't be able to use it for other purposes. You can't build on top of it. You can't put fences around it in some cases. You can't, if you wanted to sell some of your farmland off for a subdivision, you probably can't anymore because it's going to be too dangerously close to the pipeline. So there's serious problems there. They're going to cost municipalities money to be prepared for this. They only exist because of these massive federal subsidies. And they create a long-term liability in the sense of the CO2 you hope will stay underground for 100 years, but there's no guarantee. In fact, there are 2 places in Illinois where they thought they could put natural gas underground and it would stay there. They could pump it in the summer when it was cheap and take it out again in the winter when it was expensive and make a lot of money on it. And there's one called Manlove right above the Mahomet Aquifer, which is the major source of water, I think, for 5 million people in the middle of Illinois. And that one was put down there thinking the same cap rock would save it. And the natural gas, not CO2, but natural gas is bubbling up through people's wells, it's bubbling into the aquifer. They've had to close down some school buildings because the natural gas was accumulating in the basements and so on. And they've no really way of shutting it down now. It's just there and it's coming up. They've got wells being drilled in to try and suck it out of the ground before it gets to the surface, not being very successful. There's another one in Nicor further north. And so this idea that it'll stay down there for 100 years is really questionable. In some cases, pumping things down like this, like wastewater from wells, has ruptured the cap rock and has caused earthquakes. So we may have earthquake problems later on. No one can guarantee that won't happen. They say it might not, but it might as well. So just go back to this for a second. I mentioned that we were having a law being written in Illinois in the General Assembly. The reason we need a law is that there's basically no laws covering either the capture process, the pipelines, or the sequestration process. The one that says, it was written a long time ago and says CO2 capture must be good for the country or for the Illinois. It clearly, things have changed since they wrote that law. And so we're producing another one, which has been in discussion with the governor's office. We're getting a lot of good support from the governor. It deals with the conditions you have to have for capture. For example, how much water are you allowed to use? What do you have to do with the chemical byproducts and so on? What do you have to do about co-pollutants, those things that you're not going to capture because you don't try and capture them, in fact. So that's the capture side of it. The pipeline part is interesting because the regulation of pipelines is entirely managed by something called the Pipeline Hazardous Materials Safety Administration, which is a federal authority that has complete control over the design, the construction, the operation, and the maintenance of all pipelines, basically. And they just didn't get around to writing any instructions for doing CO2 pipelines. They've got a little bit for a small number of CO2 pipelines where they carry the gas at high temperature, but they don't have any instructions for the specific to normal liquid CO2 pipelines where the temperature is low. They have general rules for all pipelines. There's a certain amount of due diligence you've got to do in managing them and observing whether they're leaking and whether they're shifting due to land shifts and things like that. Those apply, but there's a complete vacuum when it comes to the construction of a liquid CO2 pipeline. So we're waiting for the PHMSA to write their rules. They say it'll take 2 years to do that, but in the meantime, there is no really good regulation over pipelines. There's one area where PHMSA can't control what happens, and that's the route of the pipeline. And that is under local control. State by state has its own rules or no rules for how a pipeline can be located. In Illinois, there are no rules for locating pipelines. The Illinois Commerce Commission has responsibility for determining the final routing of the pipeline, but there's no real science that says how far the pipeline should be from residences. We have the observation that, hi Lisa, we have the observation that at Cetacea, it should be 1.5 miles away, but the pipeline that we're putting through Illinois is 45% bigger than the pipeline in capacity between valves than the one at Cetacea. So how far apart should the houses be from the pipeline? We aren't having much luck regulating that because there are no good computer models for that sort of thing at the moment. We're trying to get those. The PHMSA guys have said you've got to have them in the future, but they don't exist at the moment. The sequestration part, the problem there is who owns the space underground where you're going to put this stuff? Does the surface owner own it? Or does somebody else? Can it be separated from the surface ownership? That's one issue. What are the regulations about pumping it down there in terms of noise and things of that sort, leakage? And the other thing is who's responsible when it's down there? The pipeline companies and the sequestration people want to say, well, the moment it's down the hole, we'll give all responsibility over to the state. If anything goes wrong after that, it's your problem, Illinois, and we'll have nothing to do with it. We're saying in our sequestration bill, yes, you will for 100 years. And we're trying to put in things that will force them to put money in up front. If anything goes wrong, that money will be there to fix it and help fix it anyhow. So there's a lot of legal problems there. We're also fighting the Navigator pipeline in the Illinois Commerce Commission. We set up a separate company. It's a not-for-profit company to fight it in there. It has members, 200 members who are all contributing money towards the fight. And we were partially successful in that Navigator filed once, and we were able to get their case dismissed because they didn't have a place to sequester the CO2. It was a pipeline to nowhere. They wanted permission to build a pipeline, but didn't have any authority to sequester the CO2 at the end of it. So we got it thrown out. They came back with one place where they think they're going to do it in Montgomery County. We'll see if that works or not. We have another application to throw this one out because they made big mistakes in how they filed the application, and also they failed to give us some documentation we think should be there. I'm not sure we're going to get this one thrown out as well, but we're in the process of getting ready to file testimony against the pipeline, and then we have to go through various rounds inside the Commerce Commission as they try to demonstrate the benefit thrown on it. Not clear that it is a benefit, but they got to show that it is, and then they got to get the route approved by the ICC, and they had to get a lot of permits from other places. We're also fighting this in the U.S. Army Corps of Engineers, because the Army Corps has to give to all water crossings. And he's got a 2-week family, and I don't fault. Okay, so we're fighting this thing on many different grounds, but it's an uphill fight, and there's just so much pressure from the government. Really, they're just being captive of the fossil fuel industry to try and build these kind of sequestration pipelines from all over the country, largely to Illinois, and also to California and other places where they can do sequestration. But I'll hold it there and just conclude by saying that if any of you read Mark Jacobson's books on the most recent one is the No Miracles Needed. Oh, you probably can't see me. No Miracles Needed is the most recent one. This paragraph here is this conclusion that in some, carbon capture is not close to a zero carbon technology. For the same energy cost, wind turbines and solar panels replacing fossil fuels produce much more carbon dioxide and also eliminate fossil fuel air pollution and mining, which carbon capture increases. Using renewables to replace fossil fuels also reduces pipelines, refineries, gas stations, tanker trucks, oil tankers, coal trains, oil spills, oil fires, gas leaks, gas explosions, international conflicts over energy. Carbon capture increases these by increasing energy use. So his position is we should not do this at all until we spent our money on eliminating coal and gas-fired power stations, electrifying our vehicles first of all. And just as an example here, the CO2 that's captured in the only place this is being done in the country, in Illinois, in the Decatur plant for ADM, they're capturing 500,000 tons a year, if lucky, often less. And their main plant generates 8.5 million tons a year of CO2. So 4.5 million tons. So 8.5 times as much CO2 is going up into the air just because of their coal-fired power station there. If they were to take the money and put it into putting in a good-sized solar farm and some windmills, they could get rid of the coal-fired power station and save 4.5 million tons instead of doing this boondoggle to get the money from the government to save 500,000 tons a year. So with that, I'll stop and see if you have any questions.
So Pam, you have your hand up. We'll take questions now.
Yeah, this is really helpful. And I wanted to ask you, I wrote to Senator Durbin about this a couple of days back, knowing that you were coming. And I asked him, since he generally is an environmental senator, generally, I asked him why this got approved and is he supportive of these pipelines? And his answer really alarmed me. And I wonder how we can mobilize to try to counteract it. His answer was that as long as the appropriate safety mechanisms are put in place, he's supportive of it because he thinks that we need, quote, all different ways to sequester carbon. We need to explore everything because the carbon problem is so huge that we need this as an alternative. And to have Durbin say that was really upsetting. And what I wonder is, how do you or we together make the case for this in a way that educates a person like a Dick Durbin that there are major problems with this, as you've described, and the risks are too great? He thinks that enough safety regulations could be put in place that we won't have the problems you've outlined.
Yeah, I'm afraid, I mean, there's a whole lot of people up in the federal government who feel that way. It's basically because they've been lobbied by the billions of dollars of fossil fuel energy. This is a way they can keep making fossil fuels and it won't have a climate impact. But the fact is, yeah, we may need all of the above, in the sense that there are certain industries like cement and steel where it is really very difficult to make those products, and we use an awful lot of them without capturing the CO2 afterwards. They just naturally produce CO2. And so we're not saying that there should be no sequestration at all, but what we're saying is that you can be you make far better use of your money if you just eliminate the CO2 coming out of the natural gas and the coal-fired power stations. You'll save an awful lot more CO2 that way for a lot less money. And then you're really starting to make a carbon negative industry and environment. And we're in the same problem that you are in talking to Durbin and Duckworth and a whole lot other people who've just been bamboozled by the industry. And it's a real discouraging thing to have to talk to them about it, I'm afraid. But we have to keep up with it. We just got to keep trying to convince them and have them try and read the science. The science says this is not the way to go. Okay,
Robin,
Robin,
you have a question?
you're on mute.
Yep, I do have a question, and thank you, Rick, by the way, for coming.
Pleasure.
Yep. So you were talking about the little village where they're already doing all this drilling and taking away all the water except the brown, dirty water. If these pipelines aren't approved yet, how are they able to do that to that land and those people just on, a trial basis?
Yeah, well, the reason is because there's nothing to prevent them doing it. They were able to buy the small piece of land. They only need an acre or so to drill a well. They can go to any of the fire hydrants anywhere in the villages and tap and fill up their tankers to bring the water in. So they put the water down the well to push up the stuff that's the soil that's being drilled up, and so on. Heaven knows where that water goes afterwards, because that often has to be disposed of in another well somewhere else. The plain fact thing is there's nothing to stop them. There's no permitting requirement for a actual sequestration well. Now,
Right.
I should say there's no permitting requirement for a monitoring well. They're calling this a monitoring well. There is a requirement for a sequestration well. It's called a Class 6 permit, and it is given by the central EPA, or it can be delegated to the states. Illinois does not have the full primacy on that to give its own approval. So they would have to get approval from the central EPA, federal EPA, in order to drill a sequestration well. But the EPA's main concern is, will it creep into the water supplies? They look at hardly anything else other than water risks. And there are many other risks besides water risks.
Yeah.
And they don't look at those hardly at all. So they would have to get more permits to build a sequestration well, but they can go ahead and drill these preliminary wells, which is what they'll need to do before they can apply for a Class 6 well.
Sure.
they've got to do some work to understand the geology in the location where they're going to do this. But they need about 24,000 acres of land to put one of these wells down and then start pumping the gas around, because it does spread around as it gets down there.
Mm-hmm.
And right now, there are no laws in Illinois that allow them to take that underground area by eminent domain, or what's called amalgamation. Amalgamation is where you say, well, we've got 80% of the landowners or 80% of the land signed up by involuntary agreements to take this CO2. We only have 20%, let's say, of landowners who aren't willing to do this. And we need amalgamation to force that 20% to take it, whether they like it or not. We'll pay them for it, but they've got to take it. So, because we can't control the CO2. Once it goes in the ground, it's going to spread out wherever it wants to go. And so if your land happens to be there, you can't route it around or anything like that. So there's lots of problems in the sequestration side, but regulations is not one of the things that's really holding it up at the moment, unfortunately.
Yeah, it's
Hey,
just
we have-
shocking that they can do that to those people relying on that water source
Yes,
without
it-
anything happening to them.
Yeah. it is.
Bruce, I think you were next.
Thank
Yep.
you.
Bruce.
Hi, Richard. Very good presentation. I learned a lot. I tried to understand what's going on. You showed a map which showed that some of the origin points for the carbon dioxide was at, I believe, natural gas wells.
Yes.
So
There are some natural gas wells. The ones I showed you were primarily from naturally occurring volcanic domes. So these are dormant volcanoes, but the gas is coming up inside them as it would do in a volcano. It's just sitting there, and you can drill into the volcano and suck it out. Then you can use it somewhere else.
So are these people doing it? Is the carbon dioxide being mined, so to speak, for beneficial? For somebody's concerned about the environment, or is this a money-making venture to
100% money-making venture for the oil companies.
for the to mine carbon dioxide?
Well, the carbon dioxide they get out of these mountains basically is piped to the oil wells and sold to the oil companies. So yes, it's being done for the money they can get from the oil wells companies for pumping it down the oil well to free up more oil.
I see. So
That's the economics of it. So
yeah, okay.
if you can pump it down the oil well, you get almost as much oil out as you got when you first drilled the oil well.
I see.
It's oil that's sitting in the rocks that wasn't able to be got out by
So it's
natural-
fracking.
It isn't necessarily in fracking wells. It's sort of like it. It doesn't actually work particularly well in fracking wells. It works best when the well just goes straight down into a pool of oil, and you can then push the CO2
I see.
and move it towards the well, then suck it out in the well and separate it and put it back down again. But
Okay.
not quite for fracking, but it's similar process.
Okay. And then two more questions. One is these pipeline ruptures, I assume because the pipeline goes through some wildlife areas, there probably has been a lot of loss of wildlife due to these ruptures. Yes.
Most of the pipelines have not ruptured because they are usually short, small, and there have been the same company that owned the Satesia pipeline owns another one in Texas area, and a month or two after the Satesia one blew up, that one blew up with a much bigger leakage of CO2, but it was in a completely rural area, so no one even knows about it.
Right.
And so no one even pays any attention to that. There's only been a couple of these huge explosions. Most of them have been small leaks when they've had a valve or something like that leak out because of the dissolving process. The other thing is that there is a reporting process that these pipeline companies are required to use to report the leaks. But if you examine that database of leaks, what you'll find is that there are 2 or 3 companies that are the biggest ones who report almost no leaks. And then there's another company that's a bigger pipeline company and they report dozens and dozens of leaks. So it's unlikely that they're exceptionally shoddy in their work, and these other guys are wonderful. It's more likely that the ones who are not reporting any are having just as many leaks as the other one does, but they just aren't bothering to report them because nobody checks, you know. So we don't really know how bad the situation is, but because it's rural and you know, straightforward, simple pipelines, they don't care very much. But when you start bringing it to Illinois, particularly the Wolf pipeline, where it comes in from near the Twin Cities, is it? Yeah, and comes down towards Decatur. That's an intensely populated area there. When we did a search, there are 18,000 different plots of land on that short stretch of pipeline. And we don't know exactly where the pipeline's going yet because the Wolf pipeline hasn't applied to the ICC for a permit yet. We thought they would do last month or the month before, but they haven't done it yet. I think they've seen the results of doing it prematurely with the other one, and they've said, we're not going to make that same mistake. Wolf is the only pipeline company that is currently operating a CO2 pipeline for sequestration company, and they're doing it in Canada. And even that is largely being used for enhanced oil recovery. But at least they've got some experience running a pipeline company. Navigator and some never run a CO2 pipeline company ever. You have no experience at all.
Bruce, why don't you finish up your questions? We're running short of time.
All right, just one more quick question. Does processes like Prairie State is using to extract the CO2, does that in addition to the chemicals, is there in addition power used to do the scrubbing? So there's it's like an infinite cycle that we don't even know if they're burning more coal to clean the coal. Oh,
and
that's
a lot
ridiculous.
more coal. I mean,
Right.
the one of these things that was claimed as being the wonder child of all these things were a power station called Petra Nova in Dallas area or somewhere in Texas anyhow. It's the state of the art in this stuff. And they had to build a separate power station, a natural gas power station, just to power the capture process for their coal-fired power station. And of course, they're not capturing the CO2 from the natural gas power station at all.
Madness.
Yeah.
Thanks.
Mike, why don't you go ahead?
Thanks. I'll be quick because it sounds like, you know, the difficulty here is that this has a reputation of being, well, this can help, you know, natural gas and coal-fired plants be bridge fuels until we get all renewable. But it doesn't sound like that at all. It sounds like we need to clarify the messages to our resident senators and others. And the three things I heard you say were, number one, what you just alluded to, that we're actually causing additional emissions that are unaccounted for, right? And additional particulate emissions because we're capturing the CO2, but not all the other crap that goes out the coal plant. That's number one. Number two, there are some dangers in transporting this thing over long distances. And number three, it sounded like you had indicated that as it's put underground, there's no guarantee it's permanently going to stay there. That we could actually have a situation of these fugitive emissions coming back out.
So you spend all this energy putting stuff down the hole, and then over the course of years, it won't be immediate, but I mean, it could be 5 years or 10 years or 100 years. It'll all come back out again, or a lot of it will come back out again. So you don't gain anything. Even if you did it the right way and sequestered it in the first place, it might leak. You can't promise it will leak. You don't know, but there's no way they can prove it won't.
All right. So the way we need to talk about this is that it's expensive and it's a net carbon loser, right? That we have to basically get away from this.
In most cases, that's true. Yeah.
Okay.
Got it.
Hey, John, go ahead.
Yeah, thank you, Richard. Just less than 10 months ago, I belong to NRDC, Environmental Defense Fund, Union of Concerned Scientists, CRP, etc. We were being told the IRA wasn't perfect, but we needed to support it. Was this known at that time, and if so, how could we have been said to support it, or has this come in later on? Where are these subsidies there? I mean, the oil companies can pressure our legislators, but they're not pressuring our experts in environmental organizations.
Yeah.
no. But I say it's come on us so quickly in the sense that until December a year ago, we'd never hardly heard of these things. And then all of a sudden, because the price went up so much, they just were exploding all over the country. There's tons of them going down in the Louisiana area because there's so much fossil fuel infrastructure down there. They're all trying to desperately save their fossil fuel plants down there by piping the CO2 into the Gulf, deep under the Gulf. There's a ton going on in California, where they want to be able to continue making cement and other things in the Central Valley. There's a lot going on down there. It isn't like it. Well, if you look at it just in isolation, you say, okay, these CO2 plants, these ethanol plants are producing 500,000 tons of CO2 a year, let's say, and we can capture it and put it underground for generating maybe 100,000 more. And so you say it's net carbon, it's carbon negative. It's true. But if you put the same amount of money into building power station, building renewable energy from solar and wind,
Exactly.
and use that to eliminate the power station, you'll be miles better off. So if you look at it in isolation, it says it's good, but if you look at it as an alternative, it's not so good.
Yeah.
Okay.
Jeff, go ahead.
Yeah, my question was related to the fact that from what you said, the two major uses right now are enhancing recovery of oil by pumping CO2, and especially in the Midwest, taking CO2 from ethanol plants.
Yeah.
So it strikes me that the corn people have a big stake in keeping this alive and keeping it going. And they're a pretty powerful lobby. Might even explain Pam Durbin's reluctance to come out more strongly against these pipelines if it's going to hurt corn producers in Illinois.
Yeah.
I think that's something that we need to look at and how to deal with that aspect of the opposition.
Absolutely right, Jeff. I didn't bring up the elephant in the room, which is the the ethanol industry. Ethanol industry only exists because of the law that was passed in 2004 in one of our oil crises, which said that all petroleum must have 10% ethanol. That created this entire industry. And it was done under the assumption that, first of all, it would save us importing oil from the Middle East, which was very expensive, $120, $150 a ton at that time, a barrel. And it would, secondly, it would reduce the air pollution from the exhaust of cars. And thirdly, it would be very favorable to the farmers. But it turned out only the farming part was positive. As soon as they passed this law, we invented fracking, and we became the world's largest exporter of petroleum. So we didn't need it to avoid importing. Turns out that when you pump it use it in a car, it does eliminate some of the CO2, and it does increase the octane of the gas, but it also produces a whole bunch more nitrogen oxides. And the nitrogen oxides are 200 times worse than CO2 as a source of global warming. So it didn't really achieve either of the results, but it's now built an entire industry where 43% of the entire arable land in the Midwest is being used for corn for ethanol.
Yeah.
And we have just decided we aren't in a position to take on the ethanol industry because we really need the farmers to say they don't want to have eminent domain and join us in the fight. So it's one of those things you just sort of have to hold your nose and keep on fighting because
we're down to 5 minutes. Cindy, your question.
Thank you, and thank you for educating us today on this topic. I had no idea that it was so significant, the impacts of sequestration, which I've never thought was really a worthwhile endeavor. But it seems like as a strategy, the best way is to fight it on all fronts, right? Like to keep making it hard, just like with pipelines in general, just keeping it really hard to get permits, to get it going, and hopefully by the time these things get through the process, it will become so burdensome and cost heavy, and the alternatives will be so much cheaper that it'll just sort of fade by the wayside. Seems like that's the best strategy, and we have to figure out maybe where we can come in on that.
You're right. You got to work on all avenues of this thing. We're working on the legal side. We're working with the farmers. We're working with the farm bureaus and everybody to try and educate them, because you say it's people don't understand it, particularly the legislators don't understand it. And they had 6,000 bills to pass in Springfield this session. So because there was a huge backlog of bills that were suppressed by Mr. Madigan. And when he's no longer there, this deluge of bills came out that he would have suppressed. And so the guys had 10 minutes to look at a bill and then had to decide whether to pass it or not. So it's a real problem. But you're right about the difficulty. Okay, go as quick as possible.
Okay, wrap it up with R. Rosen and Kevin, and then any questions in the chat, we'll try and get back to you after the meeting.
Yeah, Bob Rosenstein. Yes, it is.
Yeah.
Bob, how you doing?
Good afternoon, good evening, Rick. Thanks for a wonderful talk. Two things. We've had some first of all, we've had problems with radon emission, also with hydraulic fracking. And if we do not sequester properly the CO2, are we not going to get additional radon release? That's my first question. You want to deal with that? I'm deeply concerned about the possibility of enhanced radon emission due to the improper sequestration. That's the first question.
Well, if you drill a hole down there that far, the chances of picking up some radon somewhere along the way is not small, and so it could do. But I think the dangers of that are, if the radon comes up, more than likely the CO2 will come up as well, and it'll be a worst of both worlds. I've not heard of that being mentioned. We have heard about earthquakes and the problem in some cases where they're sequestering, they actually have to pump down to the saline well and pump out the saline to make room for the CO2 to go down there. And that's where you do sometimes get radioactive water coming up, and certainly polluted water. I should mention also that when the CO2, if it ever does get out from its cap rock and moves up into the aquifers and so on, as it gets wet, it turns into carbonic acid, and carbonic acid can leach out the heavy metals from the rocks as it goes up. So as it moves up towards the aquifer, you're going to get arsenic, chromium, lead, iron, and other things going up towards your aquifers. And you can really ruin the aquifer in the process of doing that. So there's lots of dangers from other things besides the CO2 itself coming up. Okay.
My other question relates to the post I made about the international panel, the UN panel on climate change. I've been following their report since 2009, and we know that carbon dioxide has a lifetime in the atmosphere of 1,000 years or more. So we need to sequester CO2 from the atmosphere by environmentally benign ways. And this business of the pipelines is helping us throw the baby out with the buggy. If we don't remove this excess CO2, we cannot preserve the global climate resiliency. So we have to move on that other front of preserving environmentally benign ways like photosynthesis to sequester the CO2 from the atmosphere.
Yeah, there's ways.
It is far more effective to do it with agricultural products than it is to try and do it with direct air capture. That's the other boondoggle that many of these fossil fuel companies are trying to work on, particularly Occidental Petroleum. There's got a massive plant being built to try and suck CO2 out of the atmosphere where it's so dilute that it really is hard to suck it out. You can move thousands and thousands of cubic meters of air just to get a tiny amount of CO2 out of it. Again, you're using nasty, dangerous chemicals. You're probably running these plants with energy from fossil fuel power stations, so they're putting more. It's just a nightmare. There are other ones like Climeworks in Iceland that are doing it in ways that are more environmentally sound, but huge amount of energy required to capture a relatively small amount of CO2. The number of these plants you need to make a dent in the whole country, in the whole world, is just massive. And the cost of running them, the amount of these plants it would take to make a real dent on the amount of CO2 being produced in this country would use every bit of the electricity that's currently being generated in the United States just to do the capture. Give you some idea of how warped these approaches are.
So we're out of time now, but Kevin, you have the final question.
Thanks, Tom. I think I'm very familiar with this because I do live in Central Illinois and I've been to the Sangamon County Board meeting. But I want some reinforcement in a couple of thoughts that I have. Number one, the horse is out of the barn at the federal level, thanks to Joe Manchin. This CO2 pipeline the CO2 capture is part of the Inflation Reduction Act.
Yep.
I think, in my mind, our energy is more focused. It's better spent at the state level, contacting our state senator and our state representative, because, like I said, Manchin is already. This is part of Manchin's clean coal. So I think there's nothing we can do at the federal level. Also, from what I understand by talking to Perna, that they are using eminent domain in Iowa to push this through. Am I correct on both of those assumptions?
I don't think they've got eminent domain yet in Iowa, either one of
No.
the pipelines there.
I'm in Iowa. It's eminent domain did not pass the legislature.
They're
It did
trying
not.
for it. Yeah. One thing that is interesting in Iowa, there was just a ruling from the courts there that the use of surveyors to go into somebody's land ahead of the pipeline just to plan the pipeline was declared, without paying the landowner, was declared to be unconstitutional by the Iowa Constitution. So that's going to put another spade in the works of the process in Iowa. It'll take a lot more time, and it's very expensive to do these kind of surveys if you don't get full cooperation from the landowners. Lots of things going on in Iowa. There's a huge battle going on in Iowa and in most of the states up there. Kevin, is that any last words?
I appreciate this presentation. If I could get you to come and talk to the Sangamon County Board, because we are in Sangamon County and the surrounding areas, we are very definitely concerned about this. They're farmers. It is a united front. There was a presentation at the last board meeting from Navigator. I think we are due our our own voice. I would really invite you to, if we could get you to come to Sangamon County and talk to the Sangamon County Board, even in Zoom. I think that would make a very important impression on the board members here.
We have a very active group down in the center of the state called the Coalition to Stop CO2 Pipelines. They've got a great website, and they've been very active indeed in going down to the county boards and getting some of the county boards to put in moratoriums saying no CO2 pipelines until the PIMSA guys deliver their regulations. Or they've been putting in setbacks, saying you can't do this within a mile of a house, let's say. Those may not be legal, but they've been doing it nonetheless. We have one of our members down there, Kathy Campbell, lives in Glen Arm, which is really close to where the pipeline is going to go. And she's been enormously active in talking to the Sangamon County Board. And she's been there. It's very hard to get time on the board schedules. You find you're lucky to get 5 minutes. You get 10 to 20 minutes. Sometimes we're really lucky. And the Navigator has a whole bunch of paid lobbyists running around trying to get to the board. And they've been pretty sneaky about how they do it, frankly. They've been coming and making a presentation, then they got a private hearing with the board afterwards you can't get into, or somewhat illegal. So there's a lot going on down there, and I encourage everybody to check in the Coalition to Stop CO2 Pipelines, check their website. There's also a national one called the CO2 Plenary Organization that has people working from all states together on CO2 pipelines. There's a Midwestern group that meets every Wednesday, I think it is, on this. There's an awful lot going on. A lot of very involved and very committed people fighting this, and you can watch what's going on. The encouragement to talk to your own legislator, please do that. We have this bill, House Bill 3119 is the one we're pushing. It'll probably get turned into something else. We don't think we're going to get it through this session because this session ends up tomorrow, I think, isn't it? And we're going to come back again in the fall session, the veto session in November. We're going to use the time between then and now to strengthen the bill and get more support for it. But thank you all very much for your
Thank
patience.
you. Thank you very much, Richard. We'll get the chat out to everybody. If you put your email in the chat, we'll get the link as well. Thanks very much, Richard. Appreciate it.
My pleasure. And thank you for inviting me.
Thanks for everybody for coming tonight.
Anybody who needs a lecture like this, let me know. I'm happy to do it anywhere. That should be my, it's, we're into